Assalamu alaikum warahmatullah. Hello guys. Today we will talk about logistic regression. So logistic regression is similar to linear regression, but the objective of logistic regression to predict, not to predict, to classify two classes. So logistic regression similar to linear regression, but its cost function is different. So we will use gradient descent now, and we will write Python code, but instead of using mean square error metrics, we will switch it to log loss function. So let's for now do some math, and then we will go to programming. So we don't want to use MCE because we need probability. We need to classify classes, so it should be it should be between 0 and 1. It should stay always between 0 and 1, the predictions, which means that prediction 0.9 maybe it's probability of that it belongs to class 1. If it's 0.1, it means probability that it belongs to class 0 high. So what I want to say is that we don't need mean square error. Instead, we need log loss function, so a cost function, and we will also use sigmoid. We denote it like this symbol, and it is equal to 1 divided to 1 plus, it was 1 plus e minus weight t to x. So this is very good function. And I first saw it shocked me, and it was very cool because this function allows accept any value, but the value always is between 1 and like maybe 0 here. So the function is always between 0 and 1, despite any value you give. You can test it by yourself. Wt and x here. We will use sigmoid function. So because we need to give we need to have this boundary between 0 and 1, because we will use the term that we will predict. Maybe I will write here probability of y equal to 1 given x is equal to our sigmoid function. Our sigmoid function given x, sigmoid function, which means this one, given weight and x. So which means that this one, the output of this sigmoid is probability. So probability should stay between 0 and 1, and like that. So we will use sigmoid log loss, and by using them we will also figure out or set our boundary, because the sigmoid gives probability. It gives 0.2, 0.3, 0.5, something, and we should also set boundary. For now, assume boundary is 0.5. So we are saying that any value we receive, any value we receive, which is assume which is, for example, if we get 0.5, okay, I will say it's class 1. If I receive value 0.3, I will say it is class 0. If I receive higher than 5 or 5, I will say, I assume is that it is class 1. If it's lower than 5, I will assume that it is 0. So you can change it 0.5 to 0.6 or any other value. But for now, for simplicity, let's use boundary of 0.5. Well, we have sigmoid, we know what is sigmoid, and now time for log loss. So if you watch my previous videos, we now will find this log loss, and we need to find the derivative of that function so that our gradient descent can find minimum. So I will clean it. So log loss is equal to our log loss, which means cost function, is equal to minus 1m. We get sum I equal to 1 to m, and big square, big brackets, yi logarithm of h, y, and x I, and then plus 1 minus y. This is very good cost function, and then log of 1 minus h weight x I, check. think, yeah, now it's clear. So this is cost function. This is cost function. Here assume if we receive, so assume here this h, here h weight xi is our sigmoid. Okay, assume it's our sigmoid function, which is that something, so it's sigmoid function. So this sigmoid, so we receive some value, you know, maybe we may receive 0.1 or 0.2, 0.3, and etc. And we will find logarithm of that, and we will multiply to y. And here, interesting thing is that if our class is equal to 1, belong to class 1, it will be so that we will use 1 and logarithm of something, we will find this value. And here 1 minus 1 equal to what? 0. It means we will ignore this part. This is key part of log loss function. When we have y equal to 0, it means this one becomes 0 all, we will ignore it. And this one will be 1, so we will use this log. Do you see the power of log loss here? So that if we have class 1, it ignores one part. If we have class 0, it ignores one part and it uses another part. So this is very cool function. And what we need to do now is that we need to find derivative with respect to weight. So it is how can I say, it's too long, but you know, I will give some hints so that let's find derivative of this one, and then other thing is much more easier. So that h weight xi is equal to sigmoid of weight t to x. Okay, and this x is not matrix, it is vector in I. So if we want to find sigmoid of, if we want to find derivative, that sigmoid given by that value to the derivative of that value, we will have derivative z and 1 minus sigmoid z. Yes, which means if we apply this one to our formula, it will become for this one, it will for this one, so derivative of h y w x I with respect to weight j, it will be x weight x I and 1 minus x h w 1 minus hy and x I multiplied to x j I. So this is for this one, and for this one, if you take for this one, it will be so that derivative of 1 minus h weight x I with respect to j. Can you see it? Yeah. And then it will be equal to minus h weight dot x I 1 minus h weight and then x I then multiplied x j I. It's the same, but this minus. So we have this one, we apply this one to here, we apply this one to here, and we find the derivative of total, and then overall in the end of the day, what we will receive is so in the end of the day we will receive the j of weight e derivative of z is equal to 1 over m, and it will be x j I, and it will be weight x h weight x I minus y I. This is our cost function. So we will use this cost function and in our formula, in our code, and that's done. So by using this cost function, and we found now gradient. So cost function is this, and gradient is this, and by using this gradient and epochs and learning rate, we will find weights, optimum weights, and by using our sigmoid, we will find the probability, and by using our boundaries, the value for boundary, we said 0.5, we can figure out the logistic regression. So let's go back to code. I will create new Python logistic regression. Logistic regression. So here we need to care about sigmoid, about log loss, and we will create. We need first of all create what? Create synthetic dataset. In order to create synthetic dataset, we need what? Our old friend numpy as np, and I will use matplotlib pyplot splt, and I will use sklearn.datasets from import make checkerboard. Ooh, make classification. So I need classification, so make classification. I will say, so we need n samples. So what was the code? So n samples equal to 100, enough. So I will say then n features. In order to see it clearly, we will do it 2D, number of features 2, and informative equal to, how informative, how close it, and redundant equal to 0, and random state for again reproduction of the code if 42. And if I plot y, okay, we have y, and I don't want to see this row wise array. I want to have it as column wise, so I will reshape -1 and 1, and then we have x, right? If I plot x, we have x, but as you know, we need to give intercept also. It's like bias, so I need to add is another row, first row, 1 1 1 1 1 1 1 to this array. So how I will add? So we can use, you know, np.hstack here, and I will use I will give list, and I will say np.ones. And what's the size of 1 is that it is belong to len of y, and I will say it is 1 shape, and I will give x. Let's see what will happen. We have error, cannot interpret 1 as a data type. It's not data type actually, it is should be coupled together, and thou and now. So we added 1, so our x actually is this one. Okay, we have x, we have y, we have synthetic dataset. Let's plot it. Scatter. I will plot it very quickly. So x, y, and all 0. We want it to be equal to 0, and then I need all and 0. The first column means, and then the same logic, x, y, all 0 equal to 0, and all and 1. And I think, okay, label class 0. Okay, we have class 0, and now now I will add class 1. We will say 1 1 and 1. No, there's something wrong. I am doing something wrong. So here 0 equal to 1, 0 equal to 1, and 1, 0 and 0. Make classification 100, number of features 2, number of informative 2, redundant 0, and random state reshape. So like our x is, you know, I should plot it before. So I will plot it before because our x is not good enough for that. So I will plot it now. Oh, okay, now check. Too many insert one dimension, what two in this thing. So I need this one, and now this one. Okay, see, so sorry for this small issue. And now, so we can see these data sets. So our data set, now our goal is we need to draw this line which will perfectly classify blue dots and orange dots. We can see that I can put, you know, something like this line. It will be very perfect. So now we will add 1 to the x, right? We have now our x is ready, our x matrix is ready for our multiplication. So if our x is ready, then what else we need? Guys, hint, learning rate equal to what? As traditional 0.01 epochs, 1000 enough. So what else we need? We said what? Sigmoid, right? Sigmoid receives z. I expect z is equal to our x dot weight, and we will return what? 1 divided 1 plus exponential minus z. Let me to just verify. Yeah, I think that's true. That's correct. There's no typo. Now what we need? Gradient function, and I need weight x y, and I will return you cost function. Okay, the cost of that gradient. And what we need now, we need these iterations for epoch in range epochs. What I need, so what our goal is that weight is equal to weight minus learning rate multiplied to gradient. So our gradient is what? Our gradient is gradient function. So gradient function, and I will give here x a weight x y, and I need to do these iterations many times, 1000 times, and I should initialize weight is equal to what? np dot zeros for now, and what? The x dot shape 1 and plus 1 also. So shape will be 2-dimensional. So we have shape, weight. So I need to implement gradient function. So we showed as like formula, right? So now we should put that formula into the Python NumPy code. So here we need to calculate this h as h equal to sigmoid. Sigmoid is equal to what? X to weight, and then we will get x. And what we need is that cost equal to what? Cost is equal to 1 divided m. So what is m? M is the length of samples y. Or we can say, x dot shape and 1. Check it out if you have time. 1 divided by m, and then you will get multiplication to our x dot transpose, and we will use dot product, and here h minus y. I think that's valid. So I will use one very good thing, epoch divided by 200 equal to 0, print f function epochs, and then t, and then gradient is a gradient. Let's compute gradient again. No, I don't want to compute gradient. I will say gradient. So I will replace this gradient as gradient, and I will initialize here. Gradient is equal to gradient function. So is it good? Is it good? Good. Epochs, gradient, f function. Maybe good. So let's run it. Okay, we have error. Epochs is not defined. Epochs. We are having epochs. So it was we had this gradient. So it's not error, it's not a cost function actually. So we are having these things, and it goes after each iteration, and let's see the weight, final weight, is we are having for intercept 0.01, for x1 0.9, for x2 minus 0.3. Okay, we have that things as weights. Wonderful. So most of the task is done. So now what we will do is that we need to find the y's, right? So we have that thing and y values. What will be y value? So before y value, let's create values. X values is equal to np.len space, I will say between -2 and 2, and we need 100 samples, and I will say y value is equal to what? We will say minus weight 0 plus weight 1 multiplied to x values, and then divided by weight 2. Let's see, we have weight, we have y values, x values. So actually this is not y value. We are now, I am drawing a line to clearly separate the classes. So here we have this thing, x and y, and I will plot it, plt.plot x values, and I will give y values, and I will say label equal to decision boundary. So how I took this formula is that, how I took this formula, I will tell you it a little bit later. So we have these y values, and we have plot, and I will use this plot. But can we use a plot? Okay, I think we cannot use a plot, unfortunately, but I think we can do some kind of I think we can use it, I think. So plot, we plot that thing. So if we plot, we have line only. Now let me to plot the scatters also. Y all in 0, and 0 equal to 0, and I need 1, 2, because we add 1. We have 1, and let's plot it. Okay, now much more better. So I think it's, we don't even need to use like -2, maybe like -1 to 1. That's much more better. -1 to 1. Anyway, so here our model is working because we figure out these weights. We just take the weights, we multiply weights to according x values, and we are getting the result. And that result is probability of that the given x belongs to the class 1. Now I draw this line, we call it decision boundary, and I draw it assuming 0.5. So let's go back. I will show it here. I am saying that so where is the marker? Okay, I am saying that that 0.5, right? So I want the sigmoid which receives vt to x, assuming I want this to have 0.5. Our boundary. From here, if I open this, from here I can say that I need this one to be 0 in order to make this one to work. This one, I prove it, like it's correct. And then we have this one, right? So from here, what we want is that from here we can rewrite this one as weight 0 x 0 plus weight 1 x1 plus weight 2 x2 equal to 0. See, so our x1 is 1 1 1 1, x2 is was the real value, x2 is value. So this one is in x axis, x2 in y axis. So I want to draw a plot. Okay, pay attention, click carefully. So I want to draw a plot where I want to have this x2. So I will say x2 is as y value, it will be equal to what? I will take this one and divide by this one. It will be minus weight 0 x0 plus weight 1 x1 divided by weight 2. So by doing that, this is our x2, our x1. I can draw a plot, a line, which is differentiate the points in the plot, in the graph. So that's it today. I know it might be a bit difficult, but try by yourself, write the code, logistic regression code, play around, and here what you need to remember is that what is sigmoid and what is logistic regression. We use it for classification, and that our sigmoid function results in what? It gives us a probability. The probability that the given x belongs to class 1. That's what you need remember. And it's okay to not remember these formulas, because if you know if you can prove it, if you know like resulting if one formula, you can derive to the formula again and again, but you don't need to learn, and if you don't understand it fully, that's also okay, because it's not that much important, I believe. That's all today for guys. If you have questions, ask in comments. See you next time. Bye bye.